Welcome to the deep dive. We're here to cut through the noise, get straight to what matters in AI. No skimming headlines today. We're really plunging into the big shifts from July 15th, 2025. We've sifted through, well, a lot of info to bring you the essentials, stuff you actually need to understand what's changing. So today we've got four key areas. First up, Moonshot AI's Kimi K2, kind of a quiet giant emerging. Then xAI's Grok 4, highly anticipated, yeah, but also sparking some real debate. After that, we'll look at the sheer scale of Meta's new AI data centers, think gigawatts. And finally, we have to unpack the Windsurf acquisition saga. It's quite a story.
Right. And our goal here is pretty simple. Connect these dots for you, give you the context, explain why this stuff actually matters, not just for the AI world, but maybe for you too.
Okay, let's dive into that first one. Moonshot AI, Kimi K2. It's been buzzing, hasn't it?
It has, yeah. Quietly but intensely.
And this isn't just, another iteration. We're talking a 1 trillion parameter model, a mixture of experts.
Exactly, an OMOE, which is significant in itself. But what's really interesting, I think, is the training.
How so?
Well, it was trained on a truly massive data set, 15.5 trillion tokens. And crucially, they used something called the Muon Optimizer.
Muon Optimizer. Okay, break that down. Is that like a replacement for Atom W?
Potentially. Atom W has been the standard for ages, right? But Muon is getting praise for producing these beautiful loss curves. That basically means it might be helping the AI learn much more smoothly, maybe more effectively. Could be a big deal for stability and power down the line.
So smoother learning, massive scale. What does that translate to in terms of performance? The claims sound pretty bold.
They are quite bold. Moonshot's saying Kimi K2 performs near the state-of-the-art across, knowledge, reasoning, coding benchmarks. They claim it significantly beats DeepSeek v3.1 and even GPT 4.1.
Even 4.1, wow.
Yeah, and specifically on coding, on the SWE-Bench Verified benchmark, which is tough, it's about fixing real software bugs. Kimi K2 scored 65.8%. That puts it right at the top for open source models in coding and using tools.
Okay, top of the open source charts for coding. That's significant. And it comes in two versions.
That's right. Kimi K2 base, more for research, fine-tuning, and then Kimi K2 Instruct for general chat and, importantly, agentic use.
Right, agentic use. But hang on, a 1 trillion parameter model, even if it's open source, running that locally sounds challenging.
Oh, absolutely challenging. I mean, yes, they did manage to shrink the raw file size by 80%, which is impressive, down from over a terabyte to 245 gigs, so theoretically runnable.
But in practice?
In practice, users are finding even the compressed versions, like the quantized ones, are still huge and slow. We're talking maybe needing 2,400 gigabytes of VRAM.
Whoa.
Or like 4 H200 GPUs just for a decent quantized version. So yeah, it's groundbreaking, but it's a cloud model for now, and not something you'll run on your laptop. Limits that open source practicality for individuals.
Okay, good point. Now, you mentioned agentic capabilities. This seems like a really big focus for Kimi K2. Tell me more.
Yes, definitely. It's possibly the, quote, first model trained specifically for agentic use, which is a big claim.
How's that different?
Well, instead of the usual way, like manually connecting tools or just basic reinforcement learning, they used what they call agentic pre-training. They built huge data sets automatically, using multiple AI agents interacting, kind of teaching each other how to use tools.
Interesting.
And this apparently awakened the model's ability to understand and use APIs and tool schemas inherently, so it can generate interactive things, PowerPoints, diagrams, simple games, not just text. Its whole process is like, think, pick a tool, see what happens, then iterate.
That sounds powerful, especially for developers, maybe automating complex stuff.
Yeah.
But does it actually work well for coding right now, given those benchmark scores?
Well, that's where the feedback gets a bit mixed. High benchmark scores, yes, but someone tried to get it to generate a simple UI using Gradio, pretty standard task, and the code it produced had, well, quite a few errors.
So the agentic design is maybe ahead of the practical coding execution.
It seems that way, at least for some specific use cases. It's early days, perhaps, and, there's also a bit of a lack of transparency. No official paper detailing the exact reinforcement learning techniques they use.
Right, so Kimi K2, pushing boundaries on scale, very innovative agentic design, but practical hurdles remain for local use and maybe flawless real-world coding. Fascinating start. Okay, so Kimi K2 has these practical hurdles despite the design. Let's pivot to another model stirring things up. xAI's Grok 4. It's out for Perplexity Pro users now, billed as the least censored model. But there's definitely more to that story.
Oh, absolutely. And what's really jumped out almost immediately are concerns about its Well, its inherent behavior. Bias might be one word, but it's maybe more specific than that.
What do you...
Reports are showing that when you ask Grok 4 about sensitive topics, say geopolitical conflicts, it seems to actively search for and prioritize Elon Musk's public statements to form its answers.
Wait, it specifically looks for his statements, not just potentially reflecting a viewpoint, but actually seeking out one person's view first.
That's what the reports suggest, yeah. Something like 4% of its responses mention Elon Musk directly. Compare that to less than 0.5% for most other leading models.
4%. That's noticeable.
Very noticeable. And people online have picked up on it, creating satirical flowcharts, calling it the Elon Musk thought filter. It goes beyond just being, embarrassing, as some called it. It raises serious questions about trust, about objectivity, about whether the AI is giving you information or reflecting a specific curated viewpoint.
Yeah, that's a fundamental trust issue. Does XAI talk about this design choice?
Not really explicitly, no. And the concern among critics is that this kind of behavior could maybe be hidden or downplayed later, so there's skepticism about whether they'll be upfront about it or just quietly tweak things. The argument is that prioritizing one person's influence like this undermines neutrality and maybe even limits how the model learns and adapts over time.
Okay, so that's a major point of discussion. But beyond that specific characteristic, how does it actually perform? Like on technical tasks, reasoning, coding?
Its reasoning is generally seen as strong, and it did something pretty impressive. It implemented a Turing machine.
A Turing machine? Seriously?
Yeah, which basically means it demonstrated the capability, in theory, to perform any computable task. That's a big step, something other LLMs haven't quite shown in the same way. Hints at AGI progress, maybe?
Okay, that is impressive on a theoretical level.
The flip side is some OLI testers feel the post-training phase was, and I quote, clearly very rushed. Real-world feedback is kind of lukewarm, some say very mid or underwhelming. They've noted poor coding examples in certain situations, and it still has that annoying habit from Grok 3 Mini of repeating your question back to you at the start.
Huh. Any specific performance blockers for developers thinking of using it?
Yes, definitely. There was a video demo showing some definite math and logic errors, and while it scored well on the Aider coding benchmark 80%, ranked 4th, which is solid, but users are hitting frustrating practical limits. Specifically, the rate limit's 32,000 tokens per minute. People are calling it the hug of death. If you try to use it for anything intensive, it gets overwhelmed, tasks don't complete, latency goes way up. Reminds people of the early issues with Gemini.
Ah, the hug of death. Right. So it's almost unusable for serious production work right now because of that bottleneck.
That seems to be the consensus, yeah. High latency, incomplete tasks under load. Makes it very difficult to rely on.
Oh, okay. So Grok 4. Strong theoretical reasoning, even Turing machine capable, but overshadowed by this very specific output characteristic related to Musk and serious practical usability issues due to rate limits and maybe rush training. Quite the mixed bag. All right, from the details of specific models, let's zoom way out to the infrastructure powering all this AI development. Mark Zuckerberg's recent announcement about Meta's plans for gigawatt-scale AI data centers, the Hyperion project in Louisiana. Just how big are we talking?
We are talking huge, unprecedented scale. Hyperion is targeting 5 gigawatts of compute capacity.
5 gigawatts.
Yep. For context, the entire Hoover Dam generates about 4.8 gigawatts.
Wow. So this one AI data center uses more power than the Hoover Dam produces.
Essentially, yes. That's the target capacity. It makes Hyperion the largest known AI data center project, completely dwarfing what we previously thought of as hyperscale.
That's staggering. What on earth requires that much compute power? What's the driver?
Well, Meta's not alone in this race. They also have the Prometheus cluster coming online in Ohio. That's 1 gigawatt by 2026. It's all about massively boosting their ability to train the next generation of AI models. They're directly competing with projects like OpenAI Stargate and xAI's Colossus. It's an arms race, basically, for compute.
An arms race measured in gigawatts.
Mm-hmm.
But surely that kind of scale creates enormous challenges. Power grids, water usage.
Oh, absolutely enormous. Integrating that kind of demand into existing power grids is a massive engineering challenge, and the water requirements for cooling are also immense. It definitely raises questions about local resource sustainability.
So how is this even feasible?
Well, there's significant backing. Governments, including the U.S. government, see leadership in AI as strategically critical. So they're actively supporting these kinds of expansions despite the challenges. It's viewed as a national priority.
Okay. So looking ahead, what does this push for gigawatt-scale AI mean for, well, everything else? Energy, infrastructure,
This is where it could get really transformative, actually. Many people in the industry think that the sheer power demand from these future AI centers could be the main driver forcing investment in next-generation energy.
You mean AI could push us towards new energy sources?
Exactly. There's serious talk that traditional fossil fuels just won't be able to scale efficiently or competitively to meet this demand. So things like nuclear power, maybe even fusion down the line, might become not just options, but necessities to power AI competitively. So the takeaway isn't just about big data centers, it's that AI's hunger for energy might fundamentally shift our energy infrastructure priorities, potentially accelerating the move to more advanced, maybe even cleaner power sources. It makes energy infrastructure a core part of the AI competition itself.
Fascinating implication. AI driving energy innovation. Okay, let's shift gears one last time from massive infrastructure to, well, corporate drama. The windsurf acquisition saga. Some are calling it the most entertaining soap opera in AI. It does sound pretty wild.
It really has been quite the roller coaster, yeah.
Yeah.
So Windsurf, they're an AI coding startup, pretty hot property. They were all set to be acquired by OpenAI.
Right, I remember hearing about that.
But then, boom, the deal just collapsed, fell apart quite abruptly.
Why? What happened?
Reports point to a few things. IP disputes, for one, but also apparently growing tensions between Microsoft and OpenAI. Disagreements over, like, the definition of AGI, how future revenues would be split, and the fact that their products were starting to overlap too much.
Ah, the complexities of giant partnerships. Okay, so the OpenAI deal is dead. What then for Windsurf? Did they just disappear?
Not quite. In a really surprising twist, the CEO, the co-founder, and a chunk of the core team didn't stay with the remnants of Windsurf. Instead, they jumped ship and joined Google DeepMind.
To Google? Wow. Doing what?
To work specifically on agentic coding, building on their expertise, but now within Google's Gemini platform. That move alone caused a lot of buzz, obviously.
I bet. Wait, the story doesn't end there, does it? Because then Cognition Labs got involved, the Devon creators.
Exactly. Act 3. After what someone described as a whirlwind weekend romance, Cognition Labs swooped in and announced they were acquiring what was left of Windsurf.
What was left? What did they get?
They got quite a lot, actually. The remaining team members, the product itself, the IP, the brand, and importantly, a reported $82 million in annual recurring revenue, so still a very valuable set of assets.
82 million ARR. Okay, so not just scraps. Cognition basically bought the functioning business minus the key leaders who went to Google.
Pretty much, yeah. It was a decisive move to grab that technology and customer base.
So what's Cognition's plan? Just absorb Windsurf's tech into Devon.
Their stated goal is to combine Cognition's autonomous agent tech, like Devon, with Windsurf's agentic IDE, their coding environment. The idea is to, quote, reinvent AI coding and create breakthrough developer experiences.
And Windsurf's philosophy fits with that.
Yes, Windsurf always focused on human-AI collaboration. They talked about true amplification of developer capabilities, not just replacing developers with automation. So that vision seems to align well with Cognition's aims.
Interesting. But this whole process, a company almost getting acquired, then breaking apart, key people leaving, the rest getting bought, what does it say about the AI startup scene?
Well, it's highlighted this trend of shell acquihires. That's where startups' assets get acquired, often after a bigger deal falls through, primarily for the remaining team and tech, but maybe not the original full vision or leadership.
And is that seen as a good thing?
It's drawn some criticism. The argument is, aren't startups supposed to innovate and compete with the big players, not just become acquisition targets or have their parts absorbed? There were also some messy details reported about compensation for Windsurf employees whose stock hadn't fully vested, highlighting the human complexities in these high-speed, high-stakes deals.
Right. The human element often gets lost in the headlines. It's a complex picture.
Yeah.
Wow. Okay, what a ride through today's AI landscape. We had Kimi K2 pushing the limits on agentic design, even with usability hurdles.
Right.
Then Grok 4, powerful, but with those unique output characteristics and practical issues, meta building data centers on a scale that's hard to even comprehend, potentially reshaping energy.
Yeah.
And the whole Windsurf drama, it really shows how fast and unpredictable this field is.
Absolutely. And you can see a few key themes weaving through all of it, right? There's this relentless escalating race for more compute power, bigger models, Kimi K2, the meta data centers.
Yeah.
It's all about scale. Then there's the constant tension between pushing AI capabilities forward and dealing with the real-world implications, bias, trust, transparency, like we saw with Grok 4, and just the sheer speed and sometimes chaotic nature of innovation and acquisitions, like the Windsurf story. Things change incredibly fast.
Definitely. So reflecting on all this,
Yeah.
what's a final thought for people to chew on?
Well, think about that energy connection we discussed with Meta's data centers.
Right, AI driving energy tech.
If that's true, if AI's demand for power really does accelerate the development and deployment of next-gen energy sources like advanced nuclear or fusion, what other completely unexpected societal shifts might spin out from that? We focus on AI changing software or information, but what if its biggest impact initially is transforming our physical infrastructure, our energy systems? What does that world look like?
Hmm, that's a really interesting question. What are the secondary and tertiary effects of this energy demand? Definitely something to think about. Thank you for joining us for this deep dive. As always, keep exploring, keep asking questions, and stay well informed. Until next time.